Okay, so the first part of this section really kind of gets you walking through the idea of simplifying our models, getting away from, remember, like I was saying, the complicated structural formulas and simplifying it down to maybe uh, a way to process it easier. So it gives you these pictures, and this is the computer paper I had. So I printed these that my kids were already using. But you can see that over here, this is kind of the one that I was talking about with the complicated structures. It's good for the chemistry of it, but also we need to simplify things a little bit. And so over here, they drew maybe just like a squiggly line. And while that seems really elementary and silly, it actually does a really good job of helping us process um, the structures of them at more of a macroscopic, like real life level. So think of the squiggly line as like the spaghetti noodles, okay? And so that first one is really just saying, like what information does the complicated one show you? And then what about the other one? Which one would be more useful in representing many molecules all kind of stuck together? And really, the picture on the left, the more complicated one, um, tells you the actual elements and shows how they're bonded together. It gives you way more detail. But the simple squiggly line one is faster to process. It's less complex. If the point is just to show relationship in like a pile of polymers, I think the squiggly line, as silly as it sounds, is way better at helping you process that. And so that is kind of what we're talking about here. Okay. So more complicated one versus the simpler squiggly line for number one. And you can really think of them as, like, I had my girls go get necklaces. So think of this as noodles. I didn't want to cook a bunch of spaghetti noodles and waste them because I love spaghetti, and then also have them all sticky all over my desk. So I had my girls go get fun little necklaces, and you can notice how these like slip past each other, right? Kind of like spaghetti noodles would, but they can also get tangled up depending on the situation that they're in. So think of these necklaces as your cooked spaghetti noodles, kind of moving around. So the second problem just says, if we were doing these numbers, it says to draw some polymers, like some linear polymers, just kind of a collection of them. And so this is my example of maybe what number two would be like. You just kind of draw some squiggly lines together, as kind of random as that sounds. And then the rest of the book goes through, or the rest of this page, I'm on 308 right now, under number two, talks about ductility, like how can we stretch that plastic out? What gives us that stretchability versus the like brittle snappiness of the plastic? And introduces this idea of thermoplastics, how heat can change how those plastics operate and how what their properties are, which is pretty cool. And gives you some examples, but then it switches into this idea of branched polymers. And branched polymers, I think I'm going to make a second video on that. So hang tight for the next part.